Hello everyone, let's solve problem 4 from backtracking subset 2. Let's move on to the problem statement. We will be given an array of elements which may contain duplicate values. We need to figure out possible unique subsets. Let's see what are the unique subsets we could make. One is empty subset, then subset 1 and subset 1 2. Again we got subset 1 2. As we want to maintain unique subsets, we can ignore second subset 1 2. Then we have subset 1 2 2 and subset 2 and subset 2 comma 2. Again we got subset 2, so we just ignore it. Let's see the analogy. From index 0, we can frame subset 1. From index 0, we can move towards index 1 or index 2. If we start with index 1, we just add index 1 value to subset, it becomes 1 comma 2. Once we are done with index 1, we start with index 2, but we understand that my current start index is greater than caller index and my current start index value is equal to previous index value. It means we got a duplicate combination, so it means it's time to ignore current index. That's it. This is an analogy. This will help us to solve this problem in a better way. The problem is almost same as LeetCode 78 subsets, but when I was talking about first problem, I went through recursion flow in a simplified manner, but subset 2 problem demands deep analysis of recursion flow so that we can crack the logic in a better way. So as a first statement, we sort all the input elements so that it will become easier for us to compare the elements. So let's see, we initiate a recursive call with empty subset and we have a possibility to initiate a subset from current index to n minus 1. So we can start with either index 0 or 1 or 2. Let's go with index 0. We add index 0 value to subset, so it becomes subset 1. From start index 0, we initiate a recursive call to the next index. Now caller index becomes 1. From caller index 1, we can start with either index 1 or index 2. So let's go with index 1. So we add index 1 value. Now subset becomes 1 comma 2. So from here, we initiate a recursive call to the next index. Now caller index becomes 2. From here, we start with index 2. So we add index 2 value. So it becomes 1 comma 2 comma 2. Now from start index 2, we initiate a recursive call to the next index. Now our current index is 3, which is equivalent to array length. So there is nothing to do. So we just return to the caller. Then we remove the last element from the list so that you will get an actual subset which is initiated from the caller. Now from caller index 2, we are done with all possibilities. So we just return to its parent, then remove the last element from the list. So we get again subset 1. Then from caller index 1, we are done with processing start index 1. Then we move towards start index 2. We understand that my current start index is greater than the caller index and my current start index value is equal to its previous index. It means we figure out a duplicate combination, so we just ignore current start index. With this, we are done with processing all iterations from caller index 1. Then we just return to its parent by just removing last element from the list. So you will again get empty subset. Now from main caller, we are done with processing start index 0. We just move on towards start index 1. We add start index 1 value. Now subset becomes 2. From here we initiate a recursive call to next index. Now caller index becomes 2. So it's time to move towards start index 2. We add index 2 value. It becomes 2 comma 2. Then we initiate a recursive call to the next index. Now we reached, now the current index value is equivalent to array length. So we just return to the caller, then remove the last element from the list. So with this, from caller index 2, we are done with all possibilities. So it's time to return to its parent. Then remove the last element from the list. You again get empty subset. With this, from main caller, we are done with processing starting index 0 and starting index 1. Let's move on towards starting index 2. If you closely see, my current start index is greater than the caller index and my current start index value is equivalent to previous index. It means we figure out a duplicate combination, so we just ignore the current iteration. So with this, we are done with all possibilities from main caller. One more important thing is, on every recursive call, we frame a subset, which is very important that as a first statement, we clone the subset, then add to the result. So that's it. The flow is almost equal to subset 1 problem, but it just needs deep analysis on how the index is changing on every recursive call. So let me go and explain the code. So the inputs are going to be index 0 and the given in array, empty subset and empty list. As a first statement, we sort the given input, then we initiate a backtrack call. Our backtrack call includes the index and the given input array and the subset which is passed as empty list, then the result. As a first statement, we just clone the current subset, then add to the result. Then once we are done with it, we initiate start index from caller index, then we move towards n, and on each iteration we increment the start index. Then we check whether the start index greater than caller index and the current start index value is equivalent to previous index value. Then we found a duplicate combination, so we just ignore the iteration. Otherwise, we add the current value to the subset, then we initiate a backtrack call to the next index with the updated subset. Once we are done with recursion, we just remove the last element from the list. That's it. So this will do the wonderful job. More importantly, this if block is more critical to avoid duplicate subsets. So if you don't have a clear knowledge on the call stack flow on recursion tree, you cannot catch the logic. So if you didn't get the clarity, please go back, check the recursion flow, come back here, things will be pretty much clear. Let me walk through the time complexity. If the elements are unique, obviously we make 2 power n subsets. It means 2 power n recursive calls. On every recursive call, we clone the subset and add to the result. In worst case, the subset length is n. So it is going to be n into 2 power n. When it comes to space complexity, I'm just considering about number of active stack frames can be active at any point in time, so which is going to be input length. So the space complexity will be linear. So that's it. So let me go and submit the solution. You see, as a first statement, we sort the array and this is our empty result and this is our empty subset. We initiate a recursive call with index 0 and the given input, empty subset and the empty result. As a first statement, we clone the subset and our start index is starting from caller index and moving towards n, and we check the condition if it is duplicate or not. If it is duplicate, we just skip the iteration. Otherwise, we add the current element and we initiate a recursive call to the next index with the updated subset. Once we are done with recursion, so we just remove the last element from the subset. That's it. So let me submit. So hope you like the explanation. Please do subscribe and share. Thanks for your time.